Hi, welcome to AVM IT Lab. My name is Pooja, and along with my team here on this channel, we will bring you knowledge over popular technologies in networking world. Videos presented on this channel are designed and consulted with highly experienced industry engineers with practical exposures so that we can cover not only from theories but best of the scenarios and knowledge from the practical world too. Hope you would like the information and knowledge shared on this platform. After watching video, do not forget to write your feedback in comment box. It will help and motivate us to create the material meeting your expectations. Thank you so much. Let us start the video for today.
Hello friends, this course will help you to gain knowledge on one of the emerging technology in market called software defined networking. If your profession is related to telecommunications or networking, you must have heard about some frequently used terms like VNF, NFV, SD-WAN, SDN, SD-LAN. Even though these all are somewhere related to each other, but knowing the concept and technology is essential. Hence, we have designed this course to give you in-depth knowledge on SDN, and we will try to cover all the concepts in following videos. As such, there is no prerequisite to attend this course, but we expect that you must have basic understanding of networks up to CCNA, JNCIA level, and also if you have some information or you can say knowledge about MPLS core, which is generally taken care by service providers, that would be very helpful. That would be very good if you have that exposure. Even if you do not have, I will try to cover though some basics in the same video. So let's start now. Moving on to the topics which we're going to cover in this video are overview. I will give you a quick overview of the technology. I will try to cover that why we need SDN suddenly when we have our ongoing technologies already in place. We have a big MPLS network, everywhere in the world. All providers, service providers, everyone is using MPLS technology a lot. So why suddenly we need SDN? So I'll give you some examples, some drawbacks. I will try to explain with some benefits of this new technology as well as some caveats of the old one. We will touch base on concepts of SDN and triggers why we suddenly need this. And finally, we will end this topic, or you can say this is the first video of this course. So we will end this video with SDN benefits. Expectations would be after finishing this video, you will be able to understand what is SDN, why we need SDN, and what are the benefits we're going to get using this new technology. So stay tuned to this video. These are the few acronyms I'm gonna use in this whole course, which is not only related to this video, but maybe for the following videos. Uh, the first term we're gonna use is SDN, which is like software defined network. If you see the last word is network, and whenever we hear this word network, we only think about physical wires, routers, switches, and all. We never gone through the details of network, how a network is bind to each other. What are the software components of it? What is control plane? What is data plane? How they interact with each other, and how your traffic moving, or you can say moves from one device to another device. So we're gonna focus on that part and also try to understand the concept of SDN, because when we are talking about SDN, it is the software defined part of network, which means we're gonna put everything from physical and try to extract the capabilities of a network and implement that in software. Or in another language, you can say that we will try to extract the software capabilities of a network and put them somewhere in a virtualized infra and utilize it. So there are some basic principles which you need to understand first when I'm talking about SDN, and I will explain you them in the following slides. The second definition, or you can say acronym, you can see here on your screen is NFV, which stands for Network Function Virtualization. Okay, even though The third term, VNF, you need that is more important because until unless you understand VNF, you won't be able to understand NFV. VNF is virtualized network function. And when I'm saying virtualized network function, try to divide this into two forms. One is virtualized and second is network function. What is a network function? Network function could be anything like a router, a switch, a firewall, a DPI, a web filtering server, anything. That is a network function, right? Which is serving a purpose in your network. When you virtualize that specific platform or that hardware into a virtual machine, it is called virtualized network function, which means the capability, the capacity, the function of the network element remains same, whereas you are just virtualizing it. So it becomes virtualized network function. Now, going back to the second acronym, which is NFV, if we gonna use these virtual network functions and try to deliver a service using these VNFs, it is called network function virtualization. Okay, so if I combine these two acronyms like NFV and VNF, we gonna virtualize the existing hardware machines or hardware network functions, which are like routers, switches, firewalls, etc., and use them to deliver the same service which we were delivering before using hardware machines, and that is called NFV. Now, since we are dealing with virtualized infra, we need a controller who has the capability to maintain or to organize the life cycle of these virtual machines. And there, that fourth acronym comes into picture, which is called VIM, which is Virtual Infrastructure Manager, which means Virtual Infrastructure Manager is responsible for controlling, managing the life cycles of these virtual machines and VNFs. So I can give you a couple of examples. Like if you talk about the oldest VIM, I can take example of vCenter. Okay, currently we have a lot of VIMs currently in market. Example is like OpenStack. OpenStack is again a virtual infra manager who is responsible for creating, deleting, updating, managing the life cycles of virtual infra or virtual machines. Moving to the next slide, since I already covered overview while explaining you the acronyms and all, so let me go to our next slide, which is why SDN. So when you understand, I mean, you already got some understanding that we're gonna discuss about SDN, NFV, VNF, virtualization of existing network infra and all. So why we suddenly need this SDN? What is the actual purpose? And why this SDN come into picture? Why suddenly this becomes so popular and so interesting that everybody wants to learn it? So there are certain reasons behind it. So you need to consider both positive points and negative points. Positive point associated with SDN and negative point associated with current infra. So one of the biggest challenge which we generally face with uh, old network is capacity gaps, which means you have an existing network which is currently running up and fine. Okay, you have your own customers. Your customers are currently using, let's say, 2 mbps of bandwidth or 10 mbps of bandwidth. Okay, suddenly they have a video conferencing which will allow all his sites to communicate with each other, and they are, in order to be more what do you call it, proactive, they are trying to make sure that there is no interruption during that video conferencing. So they are asking their service provider to increase the bandwidth from 2 mbps to 50 mbps for a duration of 1 week, because they're going to use that specific web conference or web meeting just for a week of time, and after that their traffic will go back to 2 mbps. So in current scenario, If you put this kind of request in front of a service provider, whosoever is giving you service, it becomes a big challenge for him because he has to make a lot of changes to give or to increase your bandwidth from 2 MB to 50 Mbps, and then he need to make sure that what amount he gonna charge for that one week of time. And after 1 week of time, there is again a need to reduce that bandwidth from 50 to 2. So a lot of issues, a lot of technical constraints are there. Also, there is a capacity gap, which means you have certain limitations. If hundreds of your customers are coming and asking you to increase the bandwidth, then definitely the provider has to think about his core bandwidth also. Because if the core is not capable of fulfilling the needs of his customers, he cannot, you know, sell that amount of bandwidth. So if we think in a traditional way where everything is fixed, and in order to increase something or decrease something, you need to play with a lot of configurations, a lot of manual efforts are required. This looks very, old fashioned. If you consider SDN technology, SDN has lots of examples which will help you to understand. If you take example of Amazon, or if you take example of Flipkart, what they are doing currently, they are managing their servers. I'm just trying to give you an example to understand how SDN can help you in expanding out and going back to the previous value. Let's say you are going to organize a big sale event, or a big billion sale event. What you're gonna do, you're gonna advertise yourself that starting from X date to Y date, you are going to uh, organize a sale. So everyone, you're gonna, if currently you are getting 100,000 hits a day, during those sale days, your count may increase to 10 million or maybe 1 billion hits. Your servers are not capable of handling that much load because they are designed either to operate at 100 million or 200 million or maximum 300 million hits. So you have two options in place. Either you increase the capacity of your physical servers, bring them down, add more resources in terms of RAM and CPU, okay, and again start them so that they are capable of taking care of 1 billion hits. But the sale duration is limited. It gonna stay only for 3 days or 4 days. So if you are adding that much of capex just to make sure that your server is capable of handling 1 billion of hits, it's wastage of money, because you are just taking or considering a probability that you may get hit by 1 billion hits on your server. It could be possible that the sale is overwhelmed by customers and there will be 10 billion hits. So again, your server will go down. Okay, so you cannot anticipate those things. When you are talking about SDN, SDN is very smart. It's gonna give you a virtual machine with minimum number of capacities. So when you are having 1 million hits, your one or two virtual machines are capable of catering that need. You set a threshold value in your SDN controller and define as soon as the number of hits are increasing 80% of the allocated value, it gonna spawn or it gonna start a parallel VM, which is the third VM, having exactly same infrastructure statistics, and gonna serve your needs in addition to the previously spawned two VMs. So now you have three VMs, which means every VM is capable of taking care of 1 million hits. Now you have added one more, it becomes 3 million. Since again the value has threshold has crossed to 80%, it will add one more VM, 4, again 5, 6, 7, 8. As long as you have defined a value that as soon as your 80% is consumed, resources are consumed or utilized, you're going to add another VM to your infra. And when the big billion days are over, your volume will start decreasing. And as soon as your volume is decreasing, your controller is going to delete those virtual machines. So customer is supposed to pay only for the duration he has big billion sale going on, and depending on the bandwidth utilized or virtual CPUs utilized or memory utilized for those n number of virtual machines, customer is just supposed to pay that. And the duration would be 3 days or 4 days as long as you have your big billion sale going on. Otherwise, the moment you come back to your previous resources, you are supposed to pay normal money. So this is the experience a customer can get and is expecting nowadays when we have SDN in place. Same kind of setup with old network elements or traditional elements is not possible because a big downtime is there. Whenever you are adding resources or removing resources, which means whenever you are scaling up or scaling down your system, your infra, your bandwidth, your capacity, there is a downtime involved. But here, there is no downtime. Okay. Another thing is security. Since you know that every customer is utilizing um, MPLS circuits, or you can say customer is asking their vendors, their service providers to give them lease line and transport their traffic on top of MPLS VPN. Why? Because they need a secure way of communication from one office to another office. 10 Mbps of circuit for a lease line comes at a cost of 25,000 to 30,000 bucks. Okay. Similarly, if you go and ask for an internet link, 100 Mbps of circuit is comes at a cost of 1,500 to 2,000 bucks for a month. So you can see there is a big difference. But the only thing is you are not secure when you are sending traffic on top of internet. So now with SDN, there are new technologies, there are new designs available in market which allow you to send your traffic on top of internet links, and they ensure that your traffic is end-to-end secure. Okay, so you are reducing the cost which you were earlier paying to your service providers in terms of point-to-point circuits, and now you are utilizing your internet bandwidth. So these are some challenges which we were facing earlier with the traditional network, because earlier there were no choice. If you need a secure communication, you have to request your service provider to give you a MPLS VPN service. But now with this SDN and this evolution in SDN is giving you more and more opportunities. Another important thing is uh, time to market. In general, what happens? Let me go to a customer diagram which I have made on a just a sec, which I have made on Paint. So you can see this is a typical service provider network. We have some PE routers here in red circles. Then you have some provider routers. In between, you have MPLS plus IGP core running. IGP could be OSPF, ISS, anything. Then on the right side and left side, you have some of your CE routers. Okay. So if I talk about a typical customer infra, you have CE routers, you could have firewalls, you could have load balancers, you could have some routers and switches internally, and then you have your LAN connected. Okay. So similarly, on the right side also, you have same network connectivity. Now, if you remember, I mean, here, when I'm talking about time to market will come into the picture whenever you try to add a new service at your customer premises. Just assume that you do not have this load balancer in place, but you need a load balancer. You have your switches, there are two switches that are directly connected to your firewall. So once you decided to put a load balancer in place, definitely you're going to contact your service provider, whosoever is giving you this service, or maybe you interact directly with the vendor to obtain a load balancer. What happens? The whole time of transporting a physical hardware from warehouse of vendor to your site and the initial ordering and processing takes months of time. In general, it is like weeks to months. So even if when you have decided that you want to put a load balancer in place, you have to wait for months to get it obtained, get it configured, and adding it to the part of your customer network. With virtual infra or with SDN, you can have this load balancer in your customer infra just in a minute of time. or just in a fraction of minutes. Why? Because you are already having the software image which you have extracted, which you called virtual network function. Okay, and you have some servers here instead of this infra. You do have some switches which are connected to your LAN and all, but after that, instead of having all this stuff, you can have something called EUCP, which is very popular nowadays. It's a small virtualization box which has the capability to to put virtual router inside, firewalls inside, load balancers inside, blue code proxies inside, everything you can put inside one box, or that is as good as your server. Okay, so spawning a virtual machine on top of that and configuring it following the SDN principles make your life easy and quick. So the time to market, if you are deploying a new technology, even you can say that, here I took example of a customer that customer wants to add, but it could be possible that your provider is helping you to build your network and he is offering you a new technology. So as long as he is supposed to push for a physical hardware, the time to market cannot be reduced because there are different teams in place. But when you are talking about software defined networking, when everything is software based, adding a new technology or adding a new hardware, a new network function is just, you know, like, uh, very quick. It's like just a fraction of second and you're going to have your service ready. Now, let's move to our next slide. Let's understand or try to understand a few more reasons why we are moving towards SDN. So we need to always make a differentiation between traditional network and the new network in order to understand SDN concepts. Okay, so let's focus about old networks. Okay, we were always saying that networks needs to be flexible, scalable, and should be always ready to fulfill their customer demands. With evolution, every service provider is expanding. He is adding more and more devices, more and more technologies, more and more complex functions into his network so that he can fulfill the needs of end customers. Okay. Now, these configurations or this network expansion in general is adding more hardware, more resources, more complexities to the network. So you need more staff to manage it. Earlier, if you were having five peoples to manage a bunch of 500 routers, now you have 5,000 routers. So in proportional to that, you need at least 50 engineers to take care of those 5,000 devices. But considering the operational expenses, no one wants to do that. So there are only two options available. Either those five engineers who were earlier managing 100 devices alone are supposed to manage 1,000 devices, okay, which is going to make their life hell. And also, with increased workload, there is a big probability that you're gonna face mistakes or you're gonna commit some mistakes or you're gonna do some, work which is not a quality work. You will only be managing with the quantity and quantity of work, but not you're not able to deliver quality. So in general, if we give you a solution where everything is centralized, which means you have your traditional equipments, which you can see in this diagram, who have forwarding, control function, management, everything inside the same box. So if you have two boxes, the user is supposed to manage these two. If you have 1,000 boxes, user or you can say administrator is supposed to manage those 1,000 individual boxes. So you can say that these traditional boxes are tightly coupled. If somehow you come up with a technology which helps you to extract the control plane of all these 1,000 boxes and centralize it to a place, and administrator has the complete control on that centralized element, controlling element. So using that single network controller, you can manage all 1,000 boxes. If you have to push single configuration in 1,000 devices. Instead of logging into each and every individual component, you can simply instruct your controlling element to push X configuration in 1,000 devices in one go. So earlier, you need more engineers, more staff to manage those individual boxes. But since you have SDN in place, which is based on centralized controlling element, you are getting more advantages, or you can say you are now more privileged in terms of managing your network because you can centrally manage everything. And this is one of the important principle of SDN. Okay, so extracting control plane out of the distributed network and putting it at a centralized location is is one of the important principle of SDN. Now this principle helps you in thousands of ways. I'm going back to my previous picture which I built on Paint just to give you some more understanding. Now just forget about the left and right customer infra and focus only on this network which is here shown in between. Let me highlight it, and you can see it in green. So this is the network. Now with increase in demand, you are expanding this network. So like I told you before, every PE router, every provider router, every individual router is currently based on a traditional following the traditional principles. So every device is running its own IGP protocol and is taking individual decisions to reach the destination from themselves. So you can see that every PE router, every provider router, every element is composing three components: forwarding plane, which is used when data comes into the picture. Okay, second is control plane, which is used to figure out how to reach a destination. And it is based on OSPF, ISIS. If I'm talking about any, dynamic protocol, you can take example of RIP and EIGRP also, but I'm just considering OSPF, ISIS here. So every device is running an instance of OSPF or ISIS, any one of the protocol or both of them, and is utilizing a lots of resources just to calculate the next hope for a destination, running thousands of SPF algorithms in background. So you can understand that how much resources are being utilized at a P if you have a full-fledged network. Something similar is happening on each and every device. Now, if you introduce SDN into your network and you make a layer of controller here, which is centralized, which has the capability to look from top of your network, and you have a controller. Now this SDN controller can help you to achieve a lots of configurations or lots of actions from a centralized place. Okay, you can see that we have an SDN controller. This SDN controller is connected to each and every device. Okay, it's making a control channel or a control connectivity with all devices and has the capability to take controlling decisions on behalf of you. So your end bodies, or you can say your provider routers or your PE routers, no longer require a decision making body. I mean, they are no longer a decision making body. They are acting as a dump terminals. If this PE router on left here wants to go to PE, this on my right side, SDN controller is going to tell you, okay, send your traffic to this provider router. Similarly, this SDN controller is going to tell this provider router, okay, forward it to this guy. From here, it will go to this guy, and this guy. This is how you can effectively manage your network resources. In general, when you have these dynamic protocols running, there are many links which are underutilized. But if you are using SDN controllers, or if you are using SDN based network controllers or virtual infra managers, they give you a centralized authority to manage the life cycle as well as your traffic functions. as well as your traffic forwarding or your traffic manipulations. Okay, which earlier you were achieving by introducing lots of complex technologies like traffic engineering and RSVP and all. I mean, these all were imposed into the network and configurations become cumbersome. So these are a couple of advantages which you can get from SDN. So you can quickly understand, I mean, what I'm trying to tell you, that why SDN is better. So I hope it is giving you much sense now when I'm saying that SDN is better. So you understood the point of centralization, which I explained you previously, that you have extracted the control plane out of the forwarding elements or out of the network elements, and those network elements are now just acting at forwarding plane. Okay, and controller who is centralized to a location can be managed by just a couple of administrators, and they can administer, configure, monitor your whole network. Adding, deleting a device is also very easy. Adding a new functionality, adding a new network flow, a new technology, introduction of new customer, everything becomes like a cup of tea for you. Okay. Also, this SDN gives you a feature called programmability, which means it is these controllers are actually exposing themselves via open APIs. Okay, and these open APIs, you might have heard about REST-based APIs and all. These all APIs are capable of understanding any language, any input, which means if you have different users, some of them are very good in PHP, some are very good in Python, and some are very good in Ruby. So using these open APIs, anyone can interact with the SDN controller. Anyone can configure or build something to configure his network controller in his own way. Okay, so there is no dependency. Currently, if you are buying a Cisco device, okay, then you are bound to follow certain things advised by Cisco, that you can only use CLI or web interface provided by Cisco to configure it or to push some configurations. But if you are using an open controller which is based on open APIs, anything can be, any XYZ application which is built in any uh, language is capable to send API requests, API calls to this SDN controller, and can push, pull any kind of resources. Okay, so these are two again enhanced advantages which you're gonna get once you introduce SDN into your network or environment. Now, let me quickly cut short this video and give you a crux. So we generally compare things or the benefits of a technology based on these 6, 7 factors. One is agility, OPEX, CAPEX, vendor independence, new business opportunities, and improved end user experience. The last one is very important because every technology depends on end user experience. So when we come talk about agility, we are kind of moving from a slower era to a faster and simpler era where everything is centralized. We do not need to wait for specific vendors or specific persons to help you configure something. Everything is based on automation, so everything is quite quick. When it comes to OPEX, since we are removing a lot of human intervention by introducing automation into a network, you are also saving your operational cost. Okay, you're also avoiding a lot of human mistakes which are generally done by persons when they are new or when they are doing or playing with something new. So here everything is automated. It you can manage it, you can control it, and you can avoid human errors. When it comes to capex, earlier you were spending your money in hardwares. Every vendor is introducing some new hardware which has a life cycle. After every 1 or 2 years, it becomes end of life. So you need to replace it. Okay, you need to replace the hardware component, and during that life cycle, you need to replace its cards, its chassis elements, its power supplies, etc. A lot of money is involved. That also introduces a lot of money in terms of capex and opex both. Okay, So by introducing this new technology, you are just investing in one thing which is called servers, and you are putting all different vendor elements on top of it using virtual network functions. So you are uh, optimizing your capex and saving opex. Now you do not have a vendor dependence, because earlier it was very tough that you have one Cisco router running, and if you introduce a Juniper, you need to think about their negotiations, which protocol has what values, what we are supposed to configure, whether they will work or not. But here you you can take an example that you are using a Dell chassis or you are using a HP chassis. That chassis is running hundreds of server inside, okay, or just a bunch of servers inside, and inside those servers you are putting these virtual network functions. So there is a complete vendor independence when it comes to Cisco, Juniper, and older vendors. Since you are moving to a new technology, you are giving opportunity to bring new business. You are more agile in terms of accepting changes, accepting customer needs, and giving them solutions. And using all this new terminology, new concepts, you are trying to enhance the end user experience. Okay, you can better manage customer services. You can give them some identity based services, like you have 100 customers, one customer is demanding a very special service, so you can put your policies based on customer identity, that whenever this guy or this user sends his data, I'm supposed to treat his traffic in a X way of forwarding. So it is giving you a lot of flexibilities when it comes to SDN. So I hope you like this video and you got some understanding why we are using SDN, why we are introducing SDN, and what are the triggers, what are the benefits of SDN. Stay tuned with my next videos, and we will try to dig more and give you more understanding. Thank you.